Hi, algebra students. So we're starting a new chapter. We're starting chapter 2, which is on inequalities. And it's a lot like what you just did in the last chapter with solving equations, only now we're going to be solving inequalities. So I'm going to share the screen and we're going to look at today's PowerPoint presentation. And it's going to start off with the warm-up. And so when I get it up here, you guys can there we go. You guys can pause the video, go ahead and try to answer the questions, and then start it back up and we can check your work. Okay, welcome back. So we have a warm-up. We're doing some comparisons of whether these things are greater than, less than, or equal to each other. So first I'm going to grab my pen. All right, here we have -2 and -5. So you have to kind of picture in your mind on a number line, which is further to the right. So the further to the right you are on a number line, the bigger the number. And since -2 is to the right of -5, -2 is greater than -5. All right, the second one, I have -5 times -8 is a +40. And on the right side, I have -40 and +40 is greater than -40. On number 3, 1/3 plus 1/3 is 2/3. 1/5 plus 1/5 is 2/5. Which is bigger? Well, we look at this denominator. 2/3 of a cake is bigger than 2/5 of a cake. So this one is greater. So far, they're all going opening to the left. All right, let's look at number 4. -3 minus a -6 is the same as -3 plus 6. So that would be 3. And on the right side, 1 plus 2 is 3. So these two are equal. All right, you have some vocabulary to write down. Let's go back. Please write these in your journal on page. I can move my little screen here. All right, you need to, these are on page 30 in your student journal. Copy down these definitions, pause the video, and we'll start back up when you finish writing. Okay, let's look at the next slide. Hopefully you got all the vocab terms written down. We're going to now use them. So exploration 1 on page 28 says, write an inequality for each statement, then sketch the graph of the numbers that make each inequality true. Okay, so it says the temperature in Sweden is at least -10 degrees Celsius. So it's at least -10. Okay, so when you see at least, that's like the least it could be. It's at least -10. So our inequality would be the temperature. Oh, forgot to grab a pen. Let's do that again. I'm going to switch color here so we can see. All right. The temperature is at least -10, which means it is greater than or equal to -10 degrees Celsius. All right. So let's see, where would that be in the number line? Well, the graph would be, it could be -10, right? It says it's at least that. But it could be here. Could it be 0? Sure. And so it'd be all of these numbers going to the right. I'm going to fill that in. It's all this side. That's nice. All right. Letter B, the elevation E of Alabama is at most 2,407 feet. That means this is the most it can be, 2,407. So like right in here. And that's the most it can be. All right, which means anything else is going to be this direction. And I realize I graphed first and didn't make the inequality, but that would be this direction. The elevation, the most it can be is 2,407, which means all the other elevations are less than that, or it could be equal to it. All right, let's look at the next slide. So it says you can use a graph to show the solutions of an inequality. An open dot is used when the point is not included in the solution. A closed dot means the solution includes the point. So an open dot is used for greater than or less than. A closed dot is used for greater than or less than or equal. So if I want to graph x is less than 8, since it doesn't include the 8, right? It's not equal to 8, I make an open circle. Anything less than 8 would be this direction. This one says x is greater than or equal to 0. So it could be equal to 0, so I close the dot. Numbers that are greater than 0 are to the right. Exploration 2, A, B, C, and D in your journal, pages 28 and 29. And I believe it says, write an inequality for the graph. Since I don't have the journal here, I'm going to grab a different color this time. Let's grab blue. All right, this time. So an inequality for this graph would be x is greater than or equal to, right? It's going to the right, so I know it's greater than. The dot is filled in, so it could be equal to. So x, the values are greater than or equal to 1. On B, I'd have x is, and again, the arrow is pointing to the right. It includes all these values here, but it does not include 1. So it's greater than 1. All right, let's look at C. So this time, filled in dot, so it could be equal to it. It's looking at values that are less than 1. So in this case, x would be less than or equal to 1. And on part D, open circle, which means we're not including it, but we're looking at values that are less than 1. They're going to the left over here, so less than 1. All right, let's look at our next slide. Extra practice, page 31, it says write each sentence as an inequality. So we're going to do some translation and write it in terms of an inequality. So it says 12 is greater than or equal to 5 times a number n. Let's look at that one. So I'm just going to start with the first word they give me is 12. It says 12 is greater than or equal to. Okay, so greater than or equal to. The next part says 5 times a number n. So 5 times a number n. And I could put a little multiplication and symbol in there, but remember, a variable next to a number implies multiplication. Okay, notice it's not asking me to solve, it just says write it as an inequality. All right, number 2, 1/3 of a number h is less than 15. So 1/3 of a number h, so I'm taking 1/3 of h, and it says that is less than 15. All right, number 3, 7 is less than or equal to the difference of a number q and 6. All right, well, I'm going to start with the easy part of it. 7 is less than or equal to something. All right, it's less than or equal to the difference. So when I see difference, I think subtraction. Less than or equal to the difference of, and what are the things we're subtracting? A number q and 6. So 7 is less than or equal to q minus 6. Number 4, the sum is addition. The sum of a number u and 14 is more than 6. So the sum of a number u, so I'm adding u and 14, and it says that is more than, okay, greater than 6. Okay. This time it says tell whether the value is a solution. So in problems like this, it's saying, all right, here's D is 19. Does 19, if I put it in here for D, does that make a true statement? All right, so let's try it. Is 19 minus 7 less than 12? That's what we want to know. Is this true? If it's true, it's a solution. If it's not true, it's not a solution. So 19 minus 7 is 12. Is 12 less than 12? And so our answer to that question would be no, it's not less than, it's equal to. And so our answer is no, it's not a solution. All right, if it had said d minus 7 is less than or equal to 12, then 19 would have been a solution. All right, let's look at number 6 this time. This time we're replacing n with 1. Okay, so we have is 9 greater than or equal to 3 times 1 plus 6. All right, let's simplify. Is 9 greater than or equal to 3 plus 6? All right, is 9 greater than or equal to 9? All right, since it has this equals on here, our answer would be yes. 1 is a solution. All right, on these next two, it asks us to graph the inequality on a number line. Now, one thing I want you to be careful of is a lot of times the students think that this points the direction of the arrow, and that's only going to be the case if our variable is on the left. If the variable is on the right side, then our arrow doesn't go in the direction of the inequality symbol, and we'll look at some of those. But on number 7, we have x is greater than or equal to 3. So 2 questions you need to ask yourself as you look at this. Is it going to be an open dot or a closed dot? And which way does the arrow go? To the left or to the right? Right. This is the questions you get to ask yourself. All right, so I start with the number 3. I go over to 3. Since the values of x I'm looking for have to be either greater than 3, that's over here, but they could be equal to 3. So since 3 is included in the solution, I fill in a dot. Numbers bigger than 3 are numbers like 4 or 5 or 200, and those are all this direction on the number line. So when you're doing these graphs on your own, I just need to see that you know the arrow goes to the right like this, right? That it's all these values. And the reason we put an arrowhead is because arrows go on forever. And so we know the solution is over there. All right, our next one, x is less than 1. So this time it's going to be an open circle because it's strictly less than. I go to 1. Nope. Sorry, I just had a dog join me. There's my dog. You want to see him? There. Now you're in the video, Gipper. Okay, sorry. So I make an open circle at 1, and I'm looking for values of x that are less than 1, which would be all the numbers over to the left. So 0 is less than 1, -5 is less than 1. All the solutions are to the left on the number line. All right, our next slide. That was fun with Gipper. Oh, next slide is your assignment. So your assignment's on page 58 in the book on Schoology. In today's agenda, I've provided a link to the appropriate pages in your book. Be sure to show your work, make number lines when you're asked to graph any solutions. There isn't a lot of work to show. I just need to see that you are finding the solutions and then graphing them in a number line. Okay, good luck.